See, I went up 1 from that 5 and then right 6.
Uh-huh.
That's your line. All right. What does this mean? Oh, I guess it doesn't give you feedback. Okay. Let's go to the next question here. All right, so this problem down here, do you see how they're giving you the line already, and it's just asking for the slope of the line. Okay, so you would just literally count how many you're going up and how many you're going to the right, but it's got to hit perfectly on the line there.
Mhm.
So hopefully you're seeing that. Like I'm seeing that you go up 1 and then right 4. So that would correspond to a fraction up 1 and right 4.
Okay.
You see that? Is it okay if I just sort of talk through these, or do you want more explanation than this?
No, you can just talk to them.
Okay. For ones that are more work, I'll definitely just go back to the screen. Oh, you've got to. Oh, I see. I don't understand. Plot twice. Okay, I'm sorry. So they want you to like do that, and they want you to graph another one here. There it is. So now it should. So it actually needed this line, this vertical line, and then this horizontal line. It should take it now. I don't know what this is. I guess it's just waiting to load. Okay. Unsubmit answer. Why would you unsubmit? All right, next question. All right, so this one we will go to the other screen for, unless you think you can calculate the slope on your own. Do you remember the slope formula?
No.
No. Okay. Fair enough. Let me go to the other screen here, and we'll look at that together. So you're seeing my screen here. The slope is y2 minus y1 over x2 minus x1. And your slopes here, or your points here, there it's an x1, y1, x2, y2. So we take that second y value 7 and then subtract that first y value 8. X2 is a minus 9, and then you subtract x1, which is negative 6. So 7 minus 8 is negative 1, minus 9 minus a minus 6 is plus 6, minus 1 over minus 3 becomes 1/3. And another way you could do this is to graph the points, but we'll go with that. Any questions on that?
No.
Okay. I'm going to submit that answer, and then I'm going to go to the next question, and I'll.
Oh, wait.
Okay, so I'm going to grab the next question here. Okay, it says to write the equation of the line in fully simplified slope intercept form. So really important that you know that form. It's y equals mx plus b.
Mm-hmm.
Okay, so m is the slope and b is the y-intercept. So the y-intercept is where it actually crosses the y-axis. Can you tell me where this crosses the y-axis down here?
The 8?
I'm sorry?
The 8 or 10?
Negative 8. Negative 8. Yeah, so b is negative 8. Now the slope, that's why they wanted you to draw this like these two lines, because it's like you go down and then you go right. You actually go down 6 and right 1. So down, when you go down with the slope, that corresponds to a negative. You're always going right. So your slope is negative 6. So you just put those into this equation here. Y equals minus 6x plus negative 8, or minus 8. Do it that way. So what this means is it goes through minus 8, and the slope is down 6 and right 1. All right, so I'm just going to submit that answer. I assume that's okay with you.
Mhm.
And we're not getting any feedback, so hopefully you get that later on. Okay, grabbing the next question here. Do you know how many total questions there are? for this review thing we're doing?
Um,
I
no.
don't, okay. All right, so it's just to factor the expression completely. The very first type of factoring that you do is what's called greatest common factor.
Mhm.
And so in this case, there's an X in both. So whatever you factor out, you end up dividing both by X.
Okay.
So we got 5 minus 4X. Okay, like that. And that's it. Like you go until you don't have anything else you can factor. So this is your answer when you're all done. So we've been doing a bunch of transformations, and of course we haven't seen any yet here. All right. Okay, so next problem here. All right, so another problem here. It says to find the distance between 2 points. Okay, and it says round to the nearest tenth if necessary. So that suggests you're going to use a calculator for this. Do you have a calculator handy, or are you just using the one from your
Oh no, I don't have one.
okay, so the distance formula says x2 minus x1 squared plus y2 minus y1 squared square rooted. So it's just like kind of like the slope. You got to label it x1 y1 and x2 y2. And so x2 is minus 6 minus 2 squared plus y2 is minus 3, y1 is 5 squared, and then you take a square root of all that. So the left here is minus 8 squared, that's 64. On the right here, it's also minus 8, that's 64. And you take a square root of that. This one does not work out perfectly, so that's why I was asking if you had a calculator, but I have one here. Rounded to the nearest tenth is 11.3.
Okay. I
Now,
think
have you seen this before? I mean, I hope you've seen it this year. Would be
yeah, I remember doing something like this.
okay.
Okay.
All right. So, because if you have like an in-person thing, like you would definitely want to know this formula. You definitely want to have that written down, or if you get a note sheet, that would be good to have. Do you have is this close out your class, or do you have more school this week?
Next week I haven't to like Thursday.
Really? All the way to Thursday. Interesting. Some students are done, some aren't, Okay.
Yeah.
Hopefully you get a little longer vacation. Okay, so these two lines are parallel, very important here. So this 59 degrees, it's the same as this angle right here because of vertical angles. And then there's a bunch of ways to do it, but these are called same side now, 59 and X. So same side angles, they add up to 180. There's a lot of ways to do this problem. This is just one of them. So that all you're doing is solving for X. So you subtract 59 from both sides. So X is 121 degrees, it looks like, with that one. So they just add up to 180, solve for X, no big deal. Make sure I added, yep. Okay. So it looks like these questions are kind of going through the course, kind of all the topics, long before we ever started working together. We probably saw some of these. Okay, so again, the lines are parallel. That's very useful. So the angles that they give you, they're on the opposite sides of what's called the transversal. They're in the interior, so they're called alternate interior angles. And you would recall that they are congruent in this case. Congruent means they equal each other, so you set them equal. Okay, and you solve for X. You subtract 5X from both sides, subtract 10 from both sides. 6X minus 5X is just X, equals 18 because everything else cancels. So these are nice. I mean, these are working out really nice so far, and probably a little bit of a relief here.
Mhm.
This. All right, so next question. Just a little lag here for some reason on the next one. Did you do anything fun this weekend?
Honestly, no. Well-
You got maybe have some fun here after the school year is over.
Yeah. All I had was like a formal, but it was boring.
Well, this is boring too. Probably. But hopefully the formal was better than this.
Yeah.
All right. Here's the diagram below. It says, so you're trying to find, it doesn't show you this, but you're trying to find the measure of angle B is what it asks for. It's just a little bit below the snip that I sent in. So it says CAD, C to A to D is 49. It's already written in there. I don't know why they're showing that. CAB. Okay, so the whole thing here is 76. So if the whole thing is 76 and you subtract out the 49, that gives you this little angle in there, which is 27 degrees. And then it says the measure of angle ADB, well, that's already given. So the net result is that you're trying to find angle B. And a lot of these problems in geometry, you have to just cut out all the extra stuff and just go get this down to the stuff you need. There's three angles in a triangle. You're missing measure B, and the three angles in a triangle, they add up to 180. So you can write a formula here: B plus 106 plus 27 equals 180, like that. And then you solve for B.
Oh, okay. I get it.
So a little bit of just manipulation here, but B ends up being 47 degrees. Again, kind of nice that these are working out so nicely. And that's it. There's probably a few other ways to do it, but this is just do it as best we can here. All right. All right, let me go back to the other screen. This looks like a proof. Do you remember doing proofs earlier in the school year?
Yeah, kind of.
Kind of. Okay, so they're saying the measure of angle BCD is 62. That's given, and then they're trying to say, well, here's the next angle that you will find. Oh my gosh, we may or may not be able to do these depending on because I don't know what order they want these in. So I guess we can also say that angle A is 62. You know what, let's do this. Let's move on to another question here. And if we finish up, we can come back to that one. That way you're getting the maximum out of this this lesson today. So let me go back to the other screen. Okay, so I remember we actually did work on some problems like this. It says, which of the following sets of numbers could represent the three sides of a right triangle? And that there's the issue is when a side is either too big or too small to work out nicely.
Mhm.
How do we want to do this here? So how do I want to explain this? We don't want to draw them. That would be no good here. But
Can we use what was it last time? Like the formula?
that's to determine whether it's a right angle or not.
Okay.
So the idea is let's say, just use a really basic example. Let's say it was 3, 4, and 5 for a triangle like
Mhm.
this. If you were to bend the 3 down so that it's along here, the longest side has to be just a little bit smaller than 3 plus 4. So that's the other way. So but then if you rotate the 3 kind of like this direction, so it's 3 and 4, the other side, 1 would be the biggest It'd have to be at least 1. So the idea is that when you subtract, so I'm sorry, when you take the 2 smaller sides and add them, so it's like A plus B, or has to be greater than C. So like the 2 smaller sides has to be greater than the third side, 2 smaller greater than the third, and you see that happens everywhere. But then the other thing is that if you take the large, if you take the largest and then the smallest and the middle one and subtract, okay, the other side has to be in there. So I think the issue is A. Sorry, I'm struggling a little bit with this. It's C minus B, C minus B. So let's see, 4 minus 3 greater than. Sorry, let me just do a quick search on this to make sure what I'm talking about here. Okay, so there's actually a better formula than this. So they do it kind of the same way. It is A plus B has to be greater than C, but then they do A plus C has to be greater than B, and then B plus C has to be greater than A. So basically, if you add up two of the sides, it has to be bigger than the third side. Always. It's like, oh, you know what? I'm so sorry. I messed all this up. You were right. This says right triangle. I apologize. A squared plus B squared equals C squared. So I totally whiffed that on that. All right, let me see if I can do this quickly for you. I made this way too complicated. All right, so the first one is correct. That has the relationship A squared plus B squared equals C squared, like you were talking about. Let's check that. All right, so then the next question is which the following could not represent. So, so there's one pair in here that just doesn't work. Oh no, this one does not represent the 3 sides of a triangle. Okay, this is where you have to do the A plus B has to be greater than C, B plus C greater than A, and A plus C greater than B. Basically, you take the 2 smaller sides, and then hopefully when you add them up, they're bigger than the third side. But see how 13 plus 20 isn't bigger than 35? So that's your answer right there. We got it on the first attempt. 13. It's only 33. So these, like, if you needed formulas for this for in person or something, that you definitely want to write that down.
Yeah.
All right, here we go. Submit that.
Oh, I think I know what this is.
Say that one more time.
I said I think I know what this is, like the next one.
We're doing some transformations. Yeah. So
Yeah.
so to me, like, I look at it and like, how do you go? You go down and then you go right. And I think it's easiest to see those translations. And the order doesn't matter. It's 2 right and then 4 down. But I mean, I look at it as 4 down and then 2 right, but it really doesn't matter. It really doesn't matter. So let's look at another one here. Okay, so the next one here, it's like, what's the transformation? And they give you options. Sometimes the options help. One of the options is y equals minus x, y equals x. Oh, they actually do clockwise rotation and clockwise. Interesting. Okay. So this is where it's like, well, maybe we should draw the line y equals x. Sure looks like it's a transformation over that. Like if you had to guess, I'd probably say it was this. It would be useful to know the formula for that transformation.
Mhm.
I don't suppose you have that handy.
No.
Okay, let me see if I can grab it here. All right, minus x minus y. You have that link. Do you happen to have that link from the last lesson that I sent you for the it's okay, I'll find it here. Okay, so y equals x means that x comma y goes to y comma x. So if we look at like point by point, so this first one is minus 1, 5. Is this point 5 on B? Is it 5 minus 1? And it is. And I probably want to check a couple more, like this minus 2, 9. Is this 9 minus 2? And it is. So I feel pretty confident saying that that's probably the transformation. But the right way to do it is really to check all the points and make sure that it actually matches what you think it should. All right. So this one, we'll go back to the other screen. So this one actually wants you to translate the figure. So we have to go point by point, 3 units left and 7 units down. So I'm gonna start here, 1, 2, 3, and then 7 down puts you at 1. Excuse me, I'm gonna go clockwise. So this is 4, this goes to 1, and then 7 down gets you to 2. This point right here is at 7, so I'm gonna go to 4, and then down to 1. That, why did it do that? Okay. Then we're gonna get this point right here, left 3, and then down 7. And then last point here, so left 3 and then down 7. How does that look to you?
Mm,
Every point's left 3 and then down 7.
yeah.
All right, so this one says to reflect the figure over the line y equals 1. We talked about last time, you basically just count. So you go up 1, so down 1. This one is down 1 as well. And then this last one, it's up here at 7. So if you count, it's 1, 2, 3, 4, 5, 6. Count 6. 1, 2, 3, 4, 5, 6. Does that fit your eye with that reflection over the line y equals 1?
Yeah.
Perfect. All right. Let's keep going here. All right, determine a series of transformation that would map figure y on the left to figure z on the right. To me, they look like they're mirrored over some sort of like vertical line here, maybe around 3. Looks like 3 or 2. I can't quite see. But I guess we do have to say for sure. It's a reflection followed by a, well, that's interesting. So like they're not allowing you to, so if we translate this over the y-axis, it would like this point right here that I'm pointing at would be kind of right here, but then we need to move it right a bunch, which is why I think they give you the translation option here. Then we got to say right, how many units, kind of, I don't know, 1, 2, 3, 4 units right. You just count the squares there and see that. And it's loading. Come on. Next question. So which angle on figure 2 corresponds to an angle on figure 1? So hopefully you can see that like D is like I, and A is like G, and B is like F, and C is like H. So the two figures are, oh, they're asking if they're congruent. They sure look congruent because only rigid motions. That sounds reasonable. And then A corresponds to, we already said that it corresponds to G. Like that, something like that. All right, determine the relationship between the two triangles and whether or not they're chosen to be congruent. So what's nice when you have a right triangle, you got two right triangles here. You only need one other side that's congruent. So there's many ways you can do this. Hypotenuse leg is the one that you use with right triangles. They're both right triangles because that box there. So if you have just one other side congruent, in this case the leg, you got it. Maybe you're going to do more proofs or more triangle congruent stuff in the next semester. All right. So this one is our last question here. Did you have other stuff you wanted to do besides this tonight, or was this it?
There's this paper.
Because probably, full disclosure, I mean, we got 21 questions done, only 12 is the only we're not doing. That's 1 point. If you need help with other stuff, it's probably better to use our time with some other stuff you need help with.
Yeah, I can send you a picture of this paper. I did like
Okay.
some of it, but I don't know if it's like right.
All right, yeah, send it over and we'll take a look. There it is. I see you sent something over. A couple of images. So we started this we did this a couple weeks ago. I think at some point. You're just trying to get down these constructions. Is that right?
Yeah.
This just like worked again. Okay. Let me get this up to where we can see it. Upload. Loading with photos. Copying an angle. Okay, I mean, this used to be an important skill. It is not anymore. I mean, we just copy stuff now the way we always do. Okay, so the idea here is you gotta copy the angle. It doesn't say where, so that's nice. What I like to do is I'll do this in different color here as well. So you extend one of the lines. In this case,
And it's like,
you say that again. I'm sorry for interrupting.
are you like on a different thing? Because it's still showing me the delta math.
Oh, I apologize. I messed that up at least once a day. Here we go. All right, so if you're seeing my screen, what is recommended is you extend one of the lines. Like if you imagine you had a ruler, you would extend this line, and then you create a dot here. And so you arc, you go back to the original one, you arc there, and then you arc there, and then you also arc up here, I believe. Then you go back to where this dot is, and then you arc here. You go back to this one, you arc here, and then you get a point to copy the angle like that. It's very similar for all the rest, but we'll grab the rest here. Let me know when you get that down.
Okay. So the other stuff I just erased, like what I did.
Yeah, you don't need any of that. I mean, it's the like what you made were angle bisectors, at least. Well, actually, I can't tell. Were you supposed to copy this? Maybe I didn't do this right. Is this the original angle, the one in red?
Mm-hmm.
Okay, so I did mess this up a little bit. You do draw a line like that, or you create another line, but you imagine you have a vertex somewhere, and you swing an arc to a point, and then, well, it's supposed to be this point here, and then you would swing the arc back on the other, like if you had a compass, you would swing it there, and then you would go to this point, you'd swing this arc, and you'd already had swung that one, so you'd get a thing like that. I mean, the line, they have to look parallel. They have to look parallel, these lines that you're drawing. The angles have to look the same. This is a real limitation of this format. So I just encourage you to do the best you can.
Okay, I got it.
All right, so let's look at number 2 and try and do a better job here. Okay, so I'll do the original. The original angle is in blue. Is that right?
Yeah.
Okay. Yeah, so again, the idea would be you extend the line of that one, and then you would go here, and you would draw like some sort of an arc that would hit both of these, and then you would, like, let's say you're copying it there, you would get an arc and get an arc like that. You would copy those, and then you come back to this point here that I'm dotting, and you'd swing another arc there. You'd swing another arc there, and you would get that second line for the angle to look, the ray in this case, to look the same.
Okay.
Let me know when you get that down. We can move on to the next one, but they're all the 3 and 4 are the same. They're not, they're going to be essentially the same types of drawings. Let me see what the other side looks like.
I'm done.
You got them all down.
Mhm.
So let me go to, like, is equal to the difference. Oh, those are harder. Okay. All right, number 3. So number 3, that's your original one. So
Mhm.
again, we would extend this out, create a new vertex point, and then just like you have here, you would swing like an arc and an arc from the vertex. So you'd have an arc and an arc, and you go back to this point and you swing another little arc, and then you connect those, and you'd have a copy of that.
Okay, got it.
Okay. So then same thing here for number 4. So you just extend that out, create a new vertex point, swing an arc, from those, swing, and you go back to that point and you swing an intersecting arc, that's not very good, so maybe somewhere there, and you get kind of that and that for the there.
Okay, got it.
Okay, so now the next couple are different. They're now asking you to find the angle, the difference in the two angles. It's kind of it's a really complicated way of saying copy the smaller angle to the larger angle.
Mhm.
So this is the smaller one. We're going to copy that over to the one on the left here, and then just identify the difference. So it's got a vertex point, you swing an arc, so you go back to that vertex point, you swing the arc, and then you swing the arc there, and you come back to this one, you swing another arc, so you get the angle copied. So the two blues are supposed to be the same. Hopefully they look really similar on yours. And then the difference between them, well, that is just the, and I'll do that in green here. That's just this other angle. That's this one. That's the difference. See, a lot of times in math, they ask you to do the same thing. They just call it something slightly different, but it's exactly the same as what you've been doing.
I'm done.
Got that down. All right. So for number 6, it's really similar. You're going to copy the smaller angle over to the other one. So you've got an arc and an arc that you already swung. Well, kind of looks like you did that anyway at some point. And then you come back to the one on the right and you swing another intersecting arc. And then you see, okay, goes like that. And then again in green will be the difference between them here. That's your difference. It's not actually asking for the angle measure. It's just asking you what to show it.
Okay, got it.
Fantastic. Equal to the difference. All right. These are the same as the others. Is that a dog I hear?
No, it's my guinea pig.
Oh, guinea pig. Okay, that's a new one. Let's lock that sound away in memory. All right, so another one on the right here kind of looks like a 90-degree angle. Maybe it is, maybe it isn't. We're going to copy the one on the right here to the one on the left because it's the smaller angle measure. The larger angles on the left. So just like, well, this is kind of a one we get to start here. You swing an arc and swing an arc. So you swing an arc and swing an arc, and then you go back to one or the other, and you swing another intersecting arc there, and that gets you the copy of it. And these are supposed to look the same. And then the difference is obviously the one where it's on the left here because it's the one that's the difference between them.
Okay.
Eight's the same. So we're going to copy the one on the right onto the one on the left, just like we've been doing. Let me grab the right color. There it is. Okay, there's your vertex point. There's your vertex point. So you swing an arc, you swing the same length arc like that. And you come back to this one here and you swing an intersecting arc. You get something that looks like that. So now the angles, they should look the same. And then the green is the difference between them.
Okay.
All right, so for number nine here, the way you make a 90-degree angle is you first draw a straight line with a ruler.
Mhm.
You pick a point somewhere, doesn't matter where it is. You swing an arc on one side and then the other, like that are the same. Then you go to each of those and you swing another arc and another arc from each of the ones you've done right and left, and then you connect those, and this is always a 90-degree angle. It's kind of amazing that this works. I mean, we don't do this by hand anymore, but there's a little appreciation for people who used to have to do this by hand. It's a lot of work actually, but it does, you can do it. It just takes time.
Okay.
Is there anything else you want us to go over? We got a couple minutes left. We could end here. Totally up to you.
No, this is all I have. I don't even
Great.
have my notebook.
Well, I hope this helps. And again, if you ever just need a lesson, you can't book it, just say, hey, Matthew, I want, 8 o'clock on Sunday night, and I'll make sure it happens for you. That way,
Okay.
you get the help you need. But thanks for letting me help you if I don't hear from you. And hope you have a great rest of your year. And I'll see you next year.
Okay.
All
Bye.
right. Bye now.